Right. Okay, so I'm Robert Asian. I'm not quite sure how this graphics got here. I think the art editor of AD kind of took the theme and did something with it. Anyway, I want to sort of declare my interest. I'm not an architect, but I'm very interested in architecture and the design process. And in particular, how do we evaluate? How do we develop a sort of informed criticism of architecture? I'm also interested in computational design tools. So my role is the developer of the design tool. But my interest, I think, or the interest of a software developer should extend beyond just the specific tools that he's developing and consider the whole process. And in particular, one of those influences is although the architect or engineer is using the design tool has some influence on the user. What is that influence? And also, what is the overall effect? We create a design tool, we give it to architects and engineers to use, but we have an interest in, well, what actually happened at the end of that process? Did we make better buildings? Were people more comfortable, and was their well-being improved? So, to go back to the title of the article in AD, T obviously means at some moment in time, and the N means really some time later. So I'm taking a little risk here, as always, because I'm going to set T to be the year 1967, which is quite some time ago. And I was a student at the Royal College of Art and Bruce Archer, who was the professor of design methods and research, was my supervisor. So I went to him and said, okay, can you suggest something interesting to do as a final year dissertation? And he said, well, there's this new area of computer-aided design coming along. Maybe you should have a look at that. And so Royal College of Art's next to Imperial College, walked across the road, and there was the first PDP-7, which I used in 1967. And to set that in a context familiar to this institution, in 1967, the magazine Clipkit was first published by Geoffrey Smythe and Peter Murray, and I shared a flat with Geoffrey Smythe, so I was popping in and out of the Architectural Association at the time. So let's just have a look at the influences. I think design methodology really proposed design as something which was systematic and goal-directed. Computer-aided design looked at the relationship, interchange between abstraction and computation as applied to design, and stretching things a little bit. The Clipkit, the Plug-in City, the Archigram moments were really saying, okay, architecture is about exploring and resolving some relationship between a context, a configuration of a building, and the components of which it's made. So the question I then ask is, well, what has happened in the intervening time? So in the article, I kind of mentioned a couple of dualities that we can think about architecture as a set of interacting engineering systems or as a social and cultural artifact. And similarly with computing, we can think of this as a set of executable abstractions, or as some kind of information artifact, an app which you play with, which has or develops a culture of use. And so we're interested in how does architecture and computation progress over time, and how do they work together? How does that interaction between design and computation also progress? So we go back a little bit before 1967 to 1963. Of course, this is the founding position of Ivan Sutherland's Sketchpad, I should say. And of course, it combines some really interesting things for the first time: real-time computing, graphic display, light pen interaction, and does anybody remember the constraint system? Okay, we think about all these superficial aspects, okay, but fundamental was there was a constraint system. And I don't know if anybody's here from Foster and Partners, but the Sage, or Swiss Re or Beijing Airport, okay, it took about 35 to 40 years for constraint systems to appear and to have some contribution on architectural practice. So that's the difference between T and T plus N. Take another example, a diagrid. I'm quite sure this is not the first use of a diagrid. This is Barnes-Wallis Wellington bomber, 1936. Okay, looks quite nice. I just took this image and just turned it around. It really makes a really good building, stand it up on end, put a different background behind it. Okay, but, there we are, 1936T, and I just pulled this out of the kind of internet, Ornamelt, a diagrid decoration facade from the Greg Lynn studio at the University of Arts in Berlin, in Vienna. Effective use of a shading device. I think we could all understand that. So looking around, and I find this image, which is a shading device popped on the north face of a building in the Northern Hemisphere. When I got hold of this image, I rang up the people who make this and said, could we use the image in AD? And I had this really fascinating conversation. Yeah, we get a lot of architects coming in. They want to modernize their buildings. They just want to we have this program that tells them how much shading the shading device will affect a window. But they don't, we give the program away, they don't use it. They just put it on the facade of the building to make the building look contemporary. Okay, so what does this tell us about an architect's understanding of the natural world? How do we, and what does that building tell the lay public about an architect's understanding? And it raises an interesting question about style and decoration. Style and decoration can accentuate something, but if it does something really wrong, isn't that kind of problematic? So, another theme, parametric design. Okay, so I was doing parametric design in about 1989 in the naval architecture that experience with Intergraph that Terry mentioned. Okay. Even drawing little diagrams to show the relationship between all the different components. Something very humble, cutting a hole in a steel plate and lining it with a flange. Okay. Parameticism, a methodologically justified style, according to world architecture. If Bruce Archer had lived to see that statement, he, would be amazed, okay? Because no amount of methodology can justify a style. A style has to exist in its cultural justification. So another transformation, okay? I try and teach this, okay? We take a square, we scale it, we rotate it, we translate it, and we share it. So I was once giving a workshop on generative components to a group of mid-career architects. Okay, so, and this lady architect at the back said, every time you introduce a new concept, you lose half the audience. So I'm not quite sure what happens, you guys, because this lady architect must have gone to a reasonable architectural school where all the ideas are flowing around. It's a really interesting place. What happens after 15 years in architectural practice that you can't simulate some new concepts? So let's take a different tack here. Let's go for an analog design system. Okay, so we have the flow rate is the scale, okay? Oh, you make your profile of your cross-section of your building. Okay, flow rate is the scale. Okay, the height is the vertical translation. The rotation, twist, gives you the rotation. And a little bit of lateral shift gives you a nice bit of shear. And if you're really good at this, you just throw in a little coordinated wobble and you get that nice inflection in the design. Okay, so you don't need to know about, translation, rotation, scale and shear. You just do it and eat the result. Enjoyable. So, but my question is, what concepts do we have to give people and how do we have to present them? so that they are properly assimilated. So I think that ecological design and the whole of this issue is, if you like, a way of countering this drift from function at T to decoration at T plus n, or not decoration but superficiality. I think it says, okay, architecture, it has to be sensible. It can be lots of other things as well. It can be entertaining, but it has to have this relationship with sense. So how, I mean, the issue that I sort of confront is, how do we build tools that are, on the one hand, immediately usable, they're very intuitive, but they're also sufficiently abstract that they've got depth, that people can do things with them if you like. I mean, the real proof of a conceptual design tool is that it can allow the user to explore concepts that the original software developer did not preconceive. So really, you want to create something which has this intuitive abstraction. So let's reset time t to today, okay, and see what we might do. We want to create, my kind of sort of hypothesis is we want to create new design tools, and they want to be based on a programming language, okay, because so we take a general purpose language and we create a special domain-specific language for design, and that essentially removes certain of the general functionality, but it adds in some of the domain-specific ideas, and it promotes them to be first-class components or features of the language. Then we make this language an end-user language. Again, we we simplify the syntax, we reduce some of the complexity, and we make it a language that is accessible to somebody who's got less experience in programming. And then, because different kinds of design, some are algorithmic, some are associative, we want to combine in this language a number of different programming styles. So we have this domain-specific, end-user, multi-paradigm language, which is what we're working on. And if you are interested in the kind of evolutionary chart, or how these things have combined, then we're combining imperative, object-oriented, functional, and declarative programming into one system, and we can look at some of the precursors of that. If this was a lecture on computer science, we might go into that in more detail. But this is one example where we've linked in, we've generated these components, we've arrayed them on a surface, and we've analyzed them with Ecotect. And so really it's based on the kind of idea of generalized scripting, generalized geometry, integration with analysis and simulation, and very important, user extensibility. So we'll be giving workshops on design script at the upcoming conferences, in the Architectural Geometry Conference in Paris, Arcadia in San Francisco in October, and at Autodesk University in November. But I want to kind of finish on a kind of more philosophical note, which is I bumped into there's going to be 3 different kind of quotations which I find quite interesting. So I was talking to a person who just graduated from MIT, who worked with me on generative components, and his comment was that he thought that technology should be invisible. And really, the implication there is that yes, you can make technology invisible if your strategy is to retrofit it to some existing workflow and not require the user of that technology to change his workflow or change his conceptualization. So yes, that's the kind of the iPhone app or something, which is totally intuitive. I'm sketching as I would have sketched before, but now it's an electronic pencil. Okay, and so these tools, they give these possibilities. They give some advantage, and advantages, can become a convenience, and then, to a certain extent, these technologies, they trap you in doing what you did before, only making it more convenient. So it becomes a convention. So so it raises the question: should design tools, make designing easier? And how could you disagree with that, except for the fact that it traps you inside these conventions? So I don't know. I remember Bill Mitchell saying something like this. I wanted, it's in the actual article. We couldn't put, okay, Bill Mitchell said, because I couldn't actually find the reference. But I was at one of the, his outstanding presentations, and essentially what he said, some tools and the way some tools are used results in a deeply conservative estimate. And it's so easy to make the building that the software was designed to make. How do we get people out of that kind of trap? So I was at SimOrd, not this year, but last year, and I remember one of the keynotes guys saying, you must model with the most appropriate formalisms at the most appropriate level of abstraction. I thought, well, that is very succinct kind of message of how one should go about, and one should be defining one's own abstraction and one's own formalism. And then this quotation from Alan Perlis, okay, if a language doesn't change the way you think, it's not worth learning. So I think that was, if you like, the message in our development of DesignScript. Yes, it's going to be a different kind of language. Why? Because we hope that it will help you think in a different way. So, and this, of course, raises the counter question to the first quote is, when is it appropriate for a technology to imply that you should change the way you think? I think the tools embody conceptual knowledge. Harnessing tools actually relieve you of actually having to do some hard work, some mechanical work. You can re-edit your tool, your design very, very easily. But essentially, you should put some hard work in as well. You should say, well, this is giving me some challenges. This tool embodies this conceptual knowledge. It's up to me to understand what that knowledge is and how to harness it. So one should never be limited by the tool. You must think beyond the tool. The tool should challenge the designer should challenge the tool. Become your own tool builder and challenge yourself.